Hello everyone. Now continuing from lesson 6 where we had an ultrasonic distance sensor and it actually gave an output to the serial monitor and we displayed the distance. We are not going to display the distance. We might, but we are going to do something else also. If the distance of the obstacle from this particular sensor is less than 30 centimeters, we will actually switch on a red LED. Otherwise, otherwise, if it is more than 30 centimeters, we will switch on a green LED. So indicating there is not much of a danger. For example, if the distance is less than 30 centimeters, there is some danger, and I need to switch on a red LED. Now, see what is going to happen now. Okay, we are going to use a breadboard, maybe. Yes, we'll use a and we'll use two LEDs. So we'll place one LED here, we'll place another LED here, we'll color, one is already red, so we'll make this as green. Okay, we have a green. We need, all right, we need an output. So that means we are going to switch them on off, no problem. So this is basically going to be connected to a digital thing. So let's connect them to digital ones. Pin number 2, we'll connect it to, I'll connect it to this. How do I beautify this? Let it be like this. And pin number 3, let me give the pin number three's output to this particular LED. So we can see that 3, we'll color this as something reddish, not red, but maybe orange. And the other one is green, so that makes sure, okay, it is color connected to. Now I need to connect the LEDs to earth also. So positives we have already connected. Let us connect them to ground. So I'll take the ground pin from here and connect it to somewhere here. Okay, what I'll do is I need a resistance for the LEDs. Okay, so what I'll do is I'll connect the LED right in the path of the earth. Okay, so let's connect the earth to it. So earth is connected, and you can see both of them are actually going to be connected to earth. So we'll connect it this one to earth and connect this one to earth. So I have made use of a single resistance to actually use to be used for both the LEDs. So you can use a similar kind of a system. Even if you have 15 LEDs, I don't need 15 resistances over there. I just need one resistance. So because the output pathways are different, so there is no problem. I'll not put my resistances there. But the return path to the ground is actually one single one. So I will use the resistance over here. So what did I actually do? You saw that I have actually connected everything. I've connected the red to pin number 2 and green to pin number 3. Okay. So let's call them as int red LED. Red LED is actually connected to pin number 2 and int green LED, which is equal to 3. And both the pins, that is red LED and green LED, are output pins because we are getting output from here. So I'll say red LED comma output, and the next one pin mode brackets green LED, comma, out. Okay, I've set up everything. Now what do we need? I'll leave the displaying of the distance here so that I can actually show you both the things. So that is the LED thing and as well as the distance on the serial monitor. Now what we need to do is we need to, if the distance of the obstacle from the sensor is less than 15, then we are going to switch on something and switch off something. So let's see that. So let me write it in plain English. So if distance distance is less than 15, then what do I need? I need to switch red on and switch green off. Otherwise, I need to switch green on and switch red off. Now this is plain English and you can figure out what is happening here. Now let us convert this into C++. How do I write? So I'll write if the variable distance is less than 15, so that is not a big deal. Braces open, braces closed, and I'll write an else and braces open and braces closed. See what has happened? I've written it in this manner. So what are we going to do here? Because we want to switch the red one on, so how do we switch it on? I'll say digital write brackets red pin comma high. I want to switch it on. And how do I switch the green one off? So I'll say digital write in brackets green pin comma low. I have switched it off. Now let me use this two statements to be written on the other side also, but I will reverse them now. I will make this as low and make this as high. I hope this makes sense to you. This should. So if the distance, that is the distance that is calculated here, is actually less than 15, its value is less than 15, it will switch on the red light and switch off the green light. Whereas if otherwise, that means it is 15 or above, then it will switch off the red light and switch on the green light. Okay. And I'll remove this part because this is plain English. So shall we run the program? Yes, we shall run the program. Let me make this a little smaller so that you can see the sensor. Let me remove this. Sorry, let me remove this. And let me bring the code in because I need the serial monitor here. Now you can see the LEDs also, you can see the sensor, you can see the serial monitor also. So let's start the simulation. So when we start, okay, there is a problem. Red pin was not declared. What was declared then? Oh, it was LED. Okay, it's not red pin, it is red LED. And this is green LED. I hope, yeah, here everything is fine. Okay, this is LED, and this is, okay, let's run the program again. Yeah, it's worked fine. Serial monitor is also started. Let me see the distance now. Now you can see the distance is more than 15 and you can see that the green LED is on now. And if I bring the distance to less, now 15 is actually going to be too less. Yes, it is now 10. You can see the red light has switched on. If I go make it go beyond 15, green light is on. So red light, green light, red light, green light, and you can see the distance that is being displayed here. See, it is 18, distance is 18, still green light is on. Distance is 12. Now it is the red light is on. Let me increase the distance. 13, red light. 15, okay, green light has started. Okay. So if it is less than 15, the red light should switch on. Now I hope this has made things clear to you. So we have taken input from ultrasonic distance sensor. We know how to work on it. We know the pulse send method, and we know how to send a burst of sound from the transmitter. Okay, we should be very clear with that. Now what we have done is we have usefully used the thing, the output of that input of that sensor to some place. Now in the next one, we are actually going to use the sensor to do something more important. More important in the sense, we will make, for example, when you find that a car in a parking lot, when a car reaches a particular point, the gate opens. So there must be some sensor which is sensing whether a car has approached, whether a car has appeared somewhere close to it, and the gate should be on. And when the car passes, the gate is closed again. So we'll do that in the next program. See you in the next video. Thank you for watching.